Hello, my name is David Durden. I'm a surface atmosphere exchange data scientist in the terrestrial instrument group at NEON. Today, I will give an overview of the terrestrial instrument system and its data products with a focus on the surface atmosphere exchange data. We start with a conceptual diagram of the terrestrial site. The tower and the soil arrays, seen here, play an important role in monitoring climate forcing variables that impact ecosystem function. Here, we can concisely see the design in action at our Niwot Ridge site. On the left, we have the tower and instrument hut. Just behind it, we can see the DFIR, or double fenced international reference for high precision and accuracy precipitation measurements. And we can see 2 of the 5 solar arrays extending into the primary airshed of the tower. This is drone footage from our NEON site at Caribou Creek in Alaska that provides a good overview of the tower instrumentation. We are monitoring profiles of wind speed and direction, temperature, photosynthetically active radiation, and biological temperature, as well as CO2 and H2O gas concentrations and isotopic ratios. At the tower top, we are heavily instrumented with radiation measurements, aerosol depth, wet and dry deposition. This is also where we'll find the turbulent exchange system, consisting of the 3D sonic anemometer and infrared gas analyzer. This slide shows a composite of all NEON tower heights across the terrestrial sites of the observatory, ranging from approximately 8 meters at the grassland and ag sites to 85 meters at the Wind River Experimental Forest site. Each tower was built to measure turbulent exchange above the roughness sublayer and outfitted with profiles to accurately measure storage components based on canopy structure at each site. This is a diagram of a soil array plot where profiles of soil moisture and soil temperature are measured down to 2 meters. We also are monitoring soil CO2 concentration profiles that allow us to calculate gradient fluxes. In addition, we measure net radiation at the surface, line average photosynthetically active radiation, soil heat flux, and throughfall. Now I'll take a little time to talk about the data processing pipeline of the instrumented system. The data that is collected by the sensors is ingested through the data loggers and sent to a computer in the instrument hut. The data are then sent back to the NEON headquarters to be stored in the Level 0 database. The data are then processed, applying calibration coefficients, plausibility tests for quality control, and any additional algorithmic processing necessary to derive the higher level data products. For the surface atmosphere exchange data processing, we utilize the development and operations, or DevOps, processing framework described in Metzger et al. 2017. We take input from the scientific community, we distill it into NEON processing algorithms, which are housed in GitHub via the EDI4R suite of R packages. Then we package them into portable Docker images that contain all the processing dependencies and are platform independent. These Docker images can then be deployed by the NEON cyber infrastructure and also utilized by the scientific community. This is a current snapshot of the eddy covariance bundled data product availability. The blue boxes represent site months where data is available for download. We are now just catching up with the scaling of the eddy covariance processing pipeline and currently running at about a month and a half latency. Though we are in the process of optimizing the surface atmosphere exchange processing pipeline to provide near real-time data with expanded daily EC files expected to be available at a 5-day latency in order to be able to perform the planar fit correction and science review flag generation. In addition, I'd like to point out that our first fully versioned dataset is expected to be available in late 2020. The EC bundled data product is provided in an HDF5 file format to store all the EC related products in a single portable file that provides provenance from the lower level products, such as the base statistics at level 1 to the fluxes at level 4. The structure was designed based on the Neon data product numbering scheme, going from the site to the data product level to the data product and then the measurement level and aggregation period. On the right here, you can see the fluxes in the file format. It also provides the metadata attributes in the file directly, applicable group or data table, and they are fully self-describing with an object description and README available in the root directory of the file. To help explore the surface atmosphere exchange HDF5 data and all Neon data products, the Neon Utilities R package is a great resource that provides functionality for downloading data from the Neon API, merging and stacking data sets, and converting file formats for interoperability. Now, I just want to mention briefly some of the ways we've been working to synthesize Neon products from the plot to the landscape scale using the environmental response functions or ERF method to take various data sources from field observations and flux data to outside resources such as satellite remote sensing and regional reanalysis, and putting those together in a machine learning framework that we can derive in situ relationships among environmental drivers and responses, thus allowing us to project measurements from the point to the model grid scale size at approximately 10 by 10 kilometers. This allows us to assess spatial variability and uncertainty associated with our measurements at the landscape scale. Lastly, I'd like to mention work that began from the NCAR Neon workshop last year, where we've begun developing tools available via GitHub to grab a host of Neon data products that are then gap filled and packaged into the defined NetCDF format for ingestion into NCAR's community land model and the Rubisco project's international land model benchmark. And we are hoping to extend this to Pecan in the near future. Thank you for your time, and I look forward to discussing how our data products can help facilitate your ecological forecasting efforts.